So before kind of talking about what the medical ceiling lift is, it's important to go over some demographics. And we say uh, over 15% of U.S. residents are over the age of 65, and the next few decades, it's projected to grow even by like 6%. Of that same category, 6% of those people are living in nursing homes, assisted homes. So these people, they require care from caretakers or medical equipment such as that. These same people are spending around $50,000 a year on average, and it's double that for people who are in these nursing homes because they got to pay for that care. And also another statistic is working Americans, about 64% of those live paycheck to paycheck. So all those statistics put together, basically there's kind of a growing problem in America where people can't afford the cost of living as they get older.
The background for a medical lift was started in the 50s. There are many different versions, mainly based on their power, including some that are manual and then some that are automatic. There are stand to sit and then ceiling mounted ones as well. Many are customizable, and the cost for a manual one could be from $400, and then a ceiling lift system could go upwards of $20,000. And depending on your insurance, it may or may not be covered from the insurance company. The medical ceiling lift helps move a patient around the room. The lift itself will lift up the patient, and then it will slide along the rails. The average lift capacity is 450 pounds with a lifetime of about 10 years in a range of 84 inches. This is to ensure the strap can get down to the ground from where it needs to go. Requirements of the system, including the area of range, the distance it has to cover, weight capacity, the material of the sling need to be machine washable and comfortable for the occupant. The material of the rails need to be easy to clean and also strong enough for and able to hold 500 pounds. It must be powered and it must be able to move.
So our goal with this project, overall, a lot of lifts out there are extremely expensive. So we wanted to design a medical ceiling that is both cheap and it meets all the customer requirements, does all the same functions, those main functions that you find in models on the market. So comparing with existing models, we have 3 models here. We got a low end, a mid-range, and a high-end lift. Kind of some qualities with the low end here is it's a 2-post freestanding lift, really lightweight. It's got a 10-foot range, only 2 positions it can kind of go into, and that's a quick assembly. So that's for the cheaper model. For kind of a mid-range average model, it's a lot more customizable. You can go with a 3-rail system room. It's a lot more reliable. There are more components. You can have in charging, in charging docks, so you don't have to plug it in. Then for a high-end model, you would extremely reliable model. It's very customizable. Software and electronics of it is very up-to-date, very top-notch. And these are some of the models you might find in a hospital. So comparing further, you can see the low-end costs are about $4,300. Moving up to some of the high-end costs are going over $10,000. Kind of some of the motor capabilities is around the same stuff, around 450 pounds. Hoist around the same weight. Range is very similar. Then some more down here. See the motors for each system is kind of very, very similar as well with those statistics.
And here we have the initial designs that we had of a ceiling mounted one, a mobile one, and then a ground support lift. And then along with The ceiling mounted one, our initial design was using a box girder. This would allow for a simple carriage to connect the I-beams to each other and to the power system. But we decided to instead go with an I-beam shape because that will be cheaper to acquire and more easier found with the cost of a more complicated carriage. And steel was, of course, chosen because of the strength of it.
Further with our initial designs, there you can see the carriage. You have 4 wheels, it's a basic box design. Main functions would just to hold the supportive weight of the system while also allowing movement in those rails. We wanted to implement a braking system, wheels, a couple of concepts. One you could turn with your hand, or maybe a push and pull rod where it can connect the carriages and the user can brake with those. So House of Quality, we decided to use a tool where we could compare both the customer requirements with the manufacturing requirements. Break this down, it's basically the dots are for a positive relationship and then triangles for a negative. And we did this for all 4 of our models, from the ceiling supported, ground supported lift, mobile, and single rail lift. Altogether, using this House of Quality, we were able to achieve the high score for our specific design with ceiling supported. And some of these qualities are weighed higher. Obviously, cost and safety is going to be weighed much higher than some other stuff like comfortability or stuff like that.
And here we have a picture of the final design with ceiling mounted lift and the carriages and the power system all being allowed to move on their rails. All the requirements are met, and not shown in the picture is the sling, the hoist, and the electronic remote. Here's a picture of the carriage design. This will allow to go along the I-beams smoothly because of the 4 wheels and hold the weight of the system. On the design, there will be 3 total of these. And on the side, we have a pulley that will act as a locking mechanism, which will stop the carriage from moving. And here we have another picture of the carriage. And because the bottom of an I-beam has a slight slant to it, the walls of the carriage had to be slanted out.
So looking at the power system for Hoist, you can see all the components labeled out here. We use a half horsepower motor connected to an 80 to 1 gearbox. This would dramatically increase torque while also decreasing the RPMs so that so our lifting speed could be very much decreased. We wanted that to safe for the patient. We don't want them to sway or go up and down too fast. Also here is a rechargeable battery for the motor and the transmitter for our wireless remote, so you don't need to plug that in. And then, of course, the spool, which would unwind the strap.
Here we have the safety locking mechanism. This will be attached to the side of the spool. It was designed from a seatbelt mechanism. In the case of the failure of the power system and the patient starts to fall downwards, the inner seat loop will slip out of its housing and pushing that metal piece out to catch the outer wall. And then this will effectively lock the spool from unspinning, preventing the person from hitting the ground. For the lift capabilities of our system, has a 550-pound capacity. It will move at 1.8 inches a second. The hoist system will be about 20 pounds, and it has all the range, and the battery life is sufficient.
So looking at our cost analysis, we were able to find all the components, all sourced online at various websites. For most of this is from Amazon and your MasterCard. Computing all this together and adding it up, we're able to achieve a very nice price at $2,400. This is before installation costs, but we are very happy with this number. Able to achieve it. So comparing with those other models stated before in our presentation, overall price, we're able to achieve a little bit less than half of the average cost of lift found on the market. When looking at installation costs, rates found around here is going to find you like 800 to 1100 for the assembly portion, and then electrician for the wiring is going to be found about 140 to $400, and then the total cost for that whole thing would be 3,300 to 3,900. It's still a lot lower than the low end that shown in the graph. So yeah, comparing further with the some of the capabilities, see that the lift speed, the lift capacity, battery life, etc. It's all kind of very similar to an average lift Mold there, 205. Some advantages with our lift over others. Obviously, the price is a lot better. Battery life will get you through a lot more cycles. With our 3-rail tracking system, you have that full room positioning, so you can go anywhere in the room. And of course, we implemented a braking system, which a lot of lifts don't even have for their wheel carriages. Some disadvantages would be it's a tough assembly since you're putting it through the ceiling and anchoring it through the drywall. There might be missing features like the electrical software and some other electrical components. And of course, manufacturing inconveniences to get all those parts online. It's tricky to source through.
Here we have the calculations for the weight capacity of the structure. It was calculated 2 ways. One using from the dimensions we calculate the moment of inertia, and then the other one was just from SolidWorks, again the moment of inertia from there, and using the equations bottom right in order to get what the max weight could possibly be, and what the deflection, and then the deflection in the middle will be at 600 pounds, will be less than 3 millimeters, so this will hardly be noticeable and won't prevent the person from being able to be pushed around. Here we have the motor capability from the RPM and the gear ratio selected, that and the radius of the spool. That'll give you a set speed that the spool will rotate at. And from that and the mass of the person, you can get the power output. And for this motor that we selected, the max weight is 550 pounds, and this could be improved with a stronger motor.
So now to our prototype, because of budgeting and assembly purposes, and we didn't have a sponsor, so building a full-scale model, it's not in our budget. We decided to go with a 1/5 scale model for mainly viewing and demonstration. So the process for this, our lift was mainly with material collecting, measuring, cutting, gluing, painting. We implemented an Arduino Uno that was coded correctly using a servo motor, and rotating knobs, so you can kind of simulate what a hoist would do, raising and lowering. Further pictures here, we have some painting done, and you can see the I-beams on the left side stacked together. On the right here, more components of our lift. We decided to go with gray paint for the whole lift system, and then the white would just be the spoons.
Here we have a picture of the finished product, and as you can see, it looks what the sling should look like, and our full-scale model will look like. And on the right, you can see close-ups of the carriage and of the power system that we used for our prototype. Here we have a video of the sling working. And of the being able to move around the room.
So safety concerns with our lift. One of the biggest concerns, obviously, poor installation. You want professionals doing this for you. Because it's on the ceiling, there could be damage to the ceiling. If it were to fail and fall, the person could be hurt, or even worse, you could also have damage to the room, which you wouldn't want. The carriages are high enough where you wouldn't have to worry about any pinching, but they are exposed, so you would want to keep fingers and material out of the way. You wouldn't want the carriage falling off the track, again, because they're exposed, so you want correct assembly for that. children and the operator, you don't want misuse by them. Also, because it is electrical components, you have to consider any potential fire hazards as well.
For possible improvements of the system, we would like to add a guide rail for the carriage or a track for the wheels. This will mitigate the potential of the carriage falling off track, a more complicated control system to allow for more than one speed. Charging mount in one of the corners would be good to charge that battery without having to remove it. And with installing additional motors, we could also allow for independent motion without having to be pushed across the road. Additionally, selecting an H-beam, which has flat flanges, would allow for a less complicated carriage and therefore making it cheaper.
Thank you. Obviously, thanks to our faculty mentors and professors, and of course, IBMU to allow us to use the facility. Any questions?
Okay, let's start it. So you ran some calculations. Right? Do you guys consider courses?
As far as that is, most of the force and the stress comes from the fact that it's a 10-foot I-beam, and that's where most of the stress comes from. The 10-foot if the load's in the middle, they'll give you a large moment. While for the perpendicular loading, that won't give you a lot of stress.
And the wheel itself, like they're showing the weight capacity when you look up the product. So obviously distribute those within 4 wheels. And it's also distributed between 3 carriages, so we decided not to do it anyways because they can hold that much weight, so it's no worry. Yeah, it was.
Any other questions? About biggest challenge and biggest
surprisingly, like the research is more of the tougher part in figuring out what we wanted to do and actually finding out like an idea and the next tasks. Actually working on the project itself and building PowerPoints and stuff and doing the calculations. That's kind of, in my opinion, the easier stuff. So definitely the creativeness and the ideas are.
Yeah, like you said, the coming up with the ideas of how do we tackle this problem, that would probably be hard. The difficult part with one with figuring out how to use SolidWorks on outside of the classroom.
and biggest tied to the challenge.
Yeah, figuring out how to work SolidWorks without having any classes that went over that and use that effectively in order to design.
Definitely a lot of self-learning, in learning projects.
Really